In today's section 8.6, solving equations with radicals, we'll be getting rid of the radical in order to find the variable. To do that, you have to think about what the exponent really is. For instance, the square root is really an exponent of half. So in order to cancel out the half to make it 1, you would square both sides. If it was a cube root, we know that the cube root is 1 to the third. So in order to make that 1, we would cube both sides. When we start solving, what we want to do is we want to try to isolate the radical. There's no other terms on either side. In this case, it is. And once that happens, you can go ahead and square both sides, in this case, because it's square root. What happens is that the square root and the square cancel out. So you're left with 5x plus 1, that equals 16. Notice I don't try to FOIL this, that the root and the exponent just cancel it out. I get 5x equals 15 and x equals 3. The one thing that you'll have to do when you're dealing with equations of radicals is you will have to plug it in. You'll plug it in to make sure it works. 5 times 3 plus 1, that gives us 15 plus 1. That's the square root of 16, which does give us 4, so it does work out. If we take a look at number 2, you'll notice the square root right here, and you'll also notice that there is this plus 2 added to the same side. Again, what I want to do is I want to isolate the radical term, and I'm going to have the square root of 5x plus 3 equal negative 2. I'll go ahead and we'll square this, and we'll get 5x plus 3 equals 4, and 5x equals 1, x is fifth. Now, I'm going to test this out, and I get 5 times 1/5 plus 3, which is square root of 1 plus 4, and I'm going to add it to 2. Sorry, that should be a 3, so square root of 4 plus 2, and you get 2 plus 2, but that doesn't equal 0. So this is called extraneous solution. And the reason why this doesn't work is if we go back to this step right here. Let's look at it without the exponent of 2, and you get square root of 5x plus 3 equals negative 2. But that first, can you have square root of a number equal negative? Which is no, so that's why that solution won't work. Question number 3, we have the square root of 5 minus x equals plus 1. You'll notice that we have the square root isolated, so we can go ahead and we can square both sides. On the right, the square root and the square cancel out, but on the right, you'll notice you're squaring a binomial, which will mean you have to FOIL. So once you FOIL that out, you get x squared plus 2x plus 1. Because it's an exponent of 2, that tells you it's quadratic. So I'm going to have to set this equal to 0. So you get 0 equals x squared plus 3x minus 4. This is factorable, so you get x plus 4, x minus 1. Therefore, x equals negative 4, and x equals 1. Again, I'm going to plug both into the equation to make sure they work. I don't get an extreme solution. So 5 minus negative 4 is square root of 9. And does that equal negative 4 plus 1? It actually doesn't. So negative 4 is our extraneous solution. So now we're going to try the 1. If I do 5 minus 1 and take the square root, does it equal 1 plus 1? Square root of 4 does equal 2. So 1 would be the only solution to this. Go ahead and copy down number 4 and pause the video and see what you get for the answer. When you're done, unpause it to see if it matches. You should get P equals 0 for your answer. Negative 2 ends up being an extraneous solution. We're going to look at an example now that has 2 radicals in the equation. Now, if you go on the fact that we talked before, I should try to isolate a radical. I will subtract square root of x and put it over here. And I'll go ahead and once it's isolated, I'll square both sides. Well, what happens is you'll notice that when I square the left side, it will cancel out. But when I go to FOIL this, there's 2 of them. Okay. And just so you notice, when I do the outsides, multiply those together, it will give me x plus 1. So now you'll notice I still have square root. What you'll have to do with that is basically you're going to have to do the process twice. So now I'm going to try to isolate that radical. So I'm going to subtract 1 and 1, so that's 2. And I'll subtract an x. So we get x plus 1 equals negative 2 square root of x plus 1. Now, although the negative 2 technically doesn't make it isolated, as a term it's isolated, we're going to leave it here and that'll be okay. I can still square both sides and not have to FOIL it. On the right, I'll get x squared plus 2x plus 1 equals 4 times quantity x plus 1. Because when I square the negative 2, it becomes 4. When I square the square root of x plus 1, the square root drops. So I'll get x squared plus 2x plus 1 equals 4x plus 4. And I'm going to set this equal to 0 because it's quadratic. And this factors into x minus 3, x plus 1. X equals 3, x equals negative 1. We're going to go ahead and do a check for both of these. When you do the check, you should find out that e does not work instantaneous, but x equals negative 2 does work. And this brings us to the last question for this section. We mentioned about cube root beginning. We'll see that the radical is isolated. So what we're going to do is we're going to cube it to get rid of the cube root. And I do that to both sides. Because both sides are isolated, both radicals step back. 2x plus 7 equals 2. I'll subtract 2x from both sides and add 2 and get